All right, party people, here we go. We are going to start today talking a little bit about macromolecules. We didn't do macromolecules yet. We talked about molecules. We know what a molecule is. Why did I say that weird? Molecules. We know what a molecule is, right? You take a couple of atoms, you put a bunch of atoms together, there you go. You form a molecule. You got a water molecule, a carbon dioxide molecule. Today we're talking about macromolecules. You know what macro means? So if I have a macromolecule, that means a big molecule. In other words, a macromolecule is a molecule where you take other molecules and kind of put them together to form one big giant molecule. It's got a completely new name than the original molecule in the first place. So I gave you all a worksheet. The worksheet I gave you says macromolecules comparison table. Bam! Flashed it real fast because I don't want you to pause and take all the answers. You got to actually pay attention and listen to my video. Don't look at my sheet. So the macromolecules that we have carbohydrates, we got lipids, we got proteins, we got nucleic acids. Those are the four big macromolecules we're going to talk about. There's plenty of macromolecules, but we're going to do those four. The reason we're going to do those four is for the rest of this school year, we're going to pile up new things. We're going to talk about genetics. Well, genetics has to do with nucleic acids. We're going to talk about energy. Well, energy has to do with carbohydrates. We're going to talk about all kinds of things going forward that are going to link us back to the macromolecules in the first place. So we've got to start with the macromolecules. If you look at your paper, that first column is carbohydrates, so that's where we're going to start. A lot of people know carbohydrates and the fact that they hear carbohydrates and they go, no, carbohydrates are bad. They turn to fat. They make you look like you, Mr. Fritsche, you got a chubby belly right there. So carbohydrates are usually a good thing. Carbohydrates are things that are going to give us some energy. As a matter of fact, you can even put that down on your functions of a carbohydrate. If you come down towards the bottom of the paper there where it says functions, they're good for short-term storage. They're real good for storage that I need right now. For instance, if I decide that I want to go and run a marathon, right? The night before, I might go to a pasta place and get myself some pasta because I need enough energy to work and do all this work that I'm doing while I'm running a marathon. Those carbohydrates are things that I need in order to give me, hold on a second. Okay, I'm good. Those carbohydrates are things that I need to give me a whole bunch of energy. It's a short-term energy source. So if I'm gonna go do something and I need energy right now real quick, carbohydrates. Those carbohydrates can come from fruits, they can come from grains. There's lots of places where carbohydrates can come from vegetables. Don't eat romaine lettuce though. Got that E. coli. All right, here we go. So here's what we got. I got a glucose molecule. That's a sugar. It ends in OSE, therefore it's a sugar. So there's my glucose. And at this point I think we should know that glucose, this is C6H12O6. Right? Now where is all that? There's a carbon, there's a carbon, there's a carbon, there's a carbon, there's a carbon. This is an oxygen, but it's attached to a carbon up here on the top. So there's our 6 carbons. Each one of those carbons has a hydrogen in there somewhere. So there's your 12, has 2 hydrogens in there somewhere. So there's your 12 hydrogens. And then there's oxygens infused in there. Obviously there's one right there. There's another one, there's 2. One comes off of here. Oh, my hydrogen, come back. Okay. One of them comes off of there. There's oxygens infused all over the place in this thing. But that is one glucose molecule. Now, I can take a glucose molecule and I can stick another glucose or another sugar molecule on top of it. For instance, I can go like this and get those 2 guys to go together. That's all well and good. That's cute. But how am I supposed to stick this together when that right there is a happy kitty and that right there is a happy kitty? They're not going to bond if they're already happy kitties. And so what's going to happen is I got to do something to make some room so I can get this guy to bond to this guy. So what I have here is I have a hydrogen. I'm going to peel this hydrogen off. Okay? That's nice. I still can't get it to stick to that. So I'm going to peel this guy off right here. Now watch this. When I peel that guy off right there, now I can get these 2. I got to make it work a little bit, but there it goes. Okay? Now I can get those 2 guys to bond together. This right here, I've already started my macromolecule. Now, how do I get these 2 to bond together? I had to take something out. Well, if I put those 2 things together, you should start to notice something. There's an H. There's another H. That's 2 H's. What was that? An O. H2O. We know about that. We just talked about water properties. I know H2O. H2O is a water molecule. So if I get a water molecule to drip out of this bad boy, that looks like blood. I should have put that with red. Should have did that. Look. Yeah, there we go. Okay, so if I drip a water molecule out of there, I can get enough water out to squeeze these two things together. That right there is called dehydration synthesis. We'll talk about that later. You don't have to write that down. If I take another one, here we go. I need another glucose molecule to stick, so I'm going to take this OH out. I'm going to take this H and pop that in there. There we go. There's another water molecule. And now I can get another glucose to stick to it. Now I've got 3 glucose molecules, one attached to another, attached to another. This right here, this macromolecule is called a carbohydrate. There we go. That molecule right there is called a carbohydrate. Okay, this is just one example of a carbohydrate. There's a bunch of examples of carbohydrates. Go back to this list real quick. Okay, that list for the examples. We have a carbohydrate that can be in plants. We have a carbohydrate that can be in humans. There's all kinds of carbohydrates. The ones that plants use, starch. Starch is the carbohydrate that a plant's going to use. During the summertime, it's all sunny out. Plants are sitting there like this all day, soaking up sunlight and enjoying them some rays. And when they get those rays, they turn those rays into glucose molecules. And when they have all those glucose molecules, they're stacking them, stacking them, stacking them, stacking them. You got stacks on stacks on stacks on stacks of carbohydrates. The reason they have to have stacks of carbohydrates is because during the fall and in the winter, when it's all chilly outside and all the leaves fall down and they ain't got no energy left, they got to sit there and go like this. How am I supposed to get me some energy? Well, how do they get energy? They go to their carbohydrate storage. Starch is their carbohydrate storage. This is great for plants, okay? We don't do starch. If we did starch, we'd be like this all the time, right? It's all clunky, weird, kind of like. Okay, so we don't do starch. We use a molecule called glycogen. Glycogen is our carbohydrate. It's what we store. So if I go and have a pasta party on Friday night before I go run a marathon on a Saturday, I'm going to pack those things in as glycogen, hold on to them for the time being so that I can go out and do my run and then start popping these glucose sauce one after another to give me a burst of energy that I need in order to do my exercise. So there we go. Things that you have to fill in for your worksheets. We're starting off with carbohydrate, the monomer of carbohydrate. This right here is a monomer. Okay, it's one piece of the bigger thing. So the monomer that we use for a carbohydrate is sugar. The polymer. This is a polymer when you bond 2 of them together, and this is a polymer when you bond 3 of them together. When you bond 2 sugar molecules together by removing a water, it's called a disaccharide. A disaccharide is a polymer of the monomer sugar. The disaccharide, if you notice the di, that means 2. This word means 2 sugars. Okay? So there's 2 sugars bonded together. If I wanted to bond all 3 sugars together, that's not a disaccharide. I'm going to give you a guess. It's a trisaccharide, right? Wrong. Wrong. It's not a trisaccharide. It's called a polysaccharide. The word poly means many. So instead of going crazy naming these guys, they just go, all right, it's either a monosaccharide, which is 1, a disaccharide, which is 2, a polysaccharide is anything above 2, past 2. All right, so the polymers. This is not a polymer, this is a sugar, or a monosaccharide. A polymer would be a disaccharide or a polysaccharide. So there's my 2 polymer words, disaccharide and polysaccharide. The elements that are involved here, well, we already have that up here. Carbon, hydrogen, oxygen. So there's my elements, C, H, and O. The examples, I give you a couple examples over here. Starch, glycogen. Okay, we can even say sucrose is an example. Table sugar, the stuff that you eat or put in your Rice Krispie treats and stuff like that. Functions, short-term energy storage is the real key for carbohydrates. All right, that's a good start. I'm happy where we are there. We're going to pause right there, and then when you're ready, we're going to do lipids.